the Sustainability Management Master's Program, you are answering one simple question. Do you care about your future generation? If you care about your kids, their grandkids, then you care about sustainability. And a sustainability manager is someone who has the tools to make people understand how they can contribute towards developing a sustainable world. We have both part-time and full-time students. Our curriculum is 30 hours. Instead of thesis, we have a research project course and a seminar course which provides them with the kind of research background they will need to be successful in their job. But at the same time, sustainability is not always everything about environment. It also relates to the business. They will take a sustainable business strategies course. They will take a project management course. Most of these courses are going to be taught by industry people, the people who are doing sustainability on a daily basis as a part of their job. Any organization that has a large number of employees and has a physical infrastructure, they will have to have a sustainability office. If you have the passion to develop and maintain a sustainable world, come to us and we will help you shape your passion into a career which will create an impact.
Welcome. Thank you so much for that wonderful introduction. And I'll just add that I met your professor a few years ago. He and I were both serving on I can't remember if it was a committee or subcommittee, but
it was a committee of ASHI, yeah.
And so for those of you who don't know, ASHI is the Association for the Advancement of Sustainability in Higher Education. It's a consortium of a lot of colleges and universities all over North America, well, the world, but mostly North America. And it focuses on how to quantify your university sustainability efforts. And it runs the gamut from the built environment to the natural environment to the academic environment and pretty much everything in between. So I am going to go ahead and hop in. I'll add for all the folks. Please feel free to interrupt me, ask questions. I like a live audience. I don't like pretending I'm talking to the morgue, and I try to make my best. I try my best to talk to folks and make it as interactive as possible. Whoops. So
Good. So anytime you have a question for Ryan, just raise your electronic hand. And if you are
yep.
there in a classroom with Parisa, just let her know. All right, go
So
ahead.
as your professor mentioned, do climate, geospatial, AI, machine learning. I'll start off with we're not going. When I say AI, I'm using it as a catchphrase, like if you were to say car. So for me, AI means something very, very different than ChatGPT. It's really we'll get. I won't get too technical on it, but it's really how we can use machines to pick up patterns, expedite our work, learn how to extrapolate features from information. So when I say AI, I'm not saying, turn me into a cat using ChatGPT. Um, so just a quick little bit about me. Been doing this for over 12 years, almost 13 years now. I've always had a strong environmental focus. I cut my teeth out of grad school doing environmental compliance up in the New England area, where I was doing some reporting related to pollution and pollution control. Was also an integral part of one of the first hazard mitigation plans on the North Shore of Massachusetts to incorporate sea level rise. We Back then, AI was still very much a very nascent thing. This was 2014, 2015 vintage. So we were just using regressions to go through the risk profiles of sea level rise for a town on the North Shore of Mass called Manchester by the Sea, which is a typical Massachusetts town on the shore. When it's by the sea, it's literally next to the ocean. And they had their town hall, which was also their police headquarters, about 150 feet away from the public boat landing. And so every time there was a high tide in a storm, it would start to lick at the basement of the building, which is where the police headquarters was. And so part of what we looked at is relocating that closer to the fire station, which was not uphill, but up gradient from there. But the issue there was there's only one way in and out of town with a severely undersized box culvert bridge. They also had the only other way that you could go in and out of the town is if you were to ride the metro, which would also at times have the tracks submerged. So it was really cool because back then nobody was talking about climate change. Um, Geospatial, I'm sure everybody knows what GIS is, or at least I hope most people do. Um, GIS, very much like AI, is a catch-all. It doesn't necessarily mean Esri, which is the ArcGIS. Uh, Essentially, with GIS, though, you're trying to understand data on a map, and so you want to understand not only where it's located, but also you can bring in temporal information as well. So how things are moving or changing over time. And what's really cool about that is from a sustainability perspective, it provides you a unique opportunity to show sustainability at your location, point it out to the various different groups, say on a campus, and also track and quantify it and see how things may change or not change over time. So I'm sure most people here have seen, oh, we have green buildings, maybe lead buildings on campus. Cool. So you could actually show where those buildings are, show what makes them lead certified, what makes them green, and as more and more technology comes on board, then we can start to get the data from those buildings and start to see how different changes in our weather impact the building's performance and actually get to a point where we can start to predict how much energy that building is going to use based not only on the weather, but also how many people are there. Is it during the school year? What's the building used for? And then as we mentioned, AI and machine learning expertise. So, in plain English, basically, AI is just teaching computers to learn from data. Everybody here pre-ChatGPT, if you did a linear regression on Excel, you technically used AI and machine learning. Excel is technically an AI tool. Um, if you are doing equations or if you're real old school and get into macros, a lot of people don't realize that. But machine learning is just a fancy way to say you're running algorithms that start to improve themselves through their experience and they find the patterns. So when I was at University of Maryland, Baltimore County, we wanted to do a university tree inventory, and we want to try to assess the canopy coverage of the university. And they were, I forget exactly how many acres, but it was over 500 acres. And so we actually used something called unsupervised machine learning to look at where the trees were showing up on satellite imagery. And then we brought in LiDAR as well so we could calculate the height of the trees. And through using the unsupervised learning, we were able to segment the canopy of all the different trees as well. And so we ended up building out a pretty comprehensive study of all the trees on campus. We are able to estimate to a fair degree of accuracy. I forget exactly what it was, but it was north of 80%. How high or how tall the trees were, and then we did some random field sampling for DBH. So that's diameter of breast height. It's a forestry measurement where essentially you stand at the tree, you go up to about here on your chest, you measure how big the tree is, what its diameter is, and then based on the tree and the tree species, you can get a good estimate of approximately how old that tree is. And so I'm sure some people are thinking, well, why? Who cares? That allows you to estimate what its carbon sequestration is, both how much it has sequestered over time, what it's doing annually, and then you could actually start to. I'm not a tree guy, a tree PhD, but there are some people then who can extrapolate out using machine learning to say, well, this tree has another, probably on average, another 70 years in its life. This is its carbon sequestration potential. And all this is important to understand because if you're familiar with carbon credits, there's this lack of monitoring in some instances, where the monitoring is, yes, the tree is still alive. And so folks are paying money, they're buying these carbon credits, these carbon offsets, but the disconnect is they can't actually prove that it's sequestering this amount of carbon. So then you run into this idea of greenwashing, where you're saying, "Oh yeah, my widget that I'm making is carbon neutral because I'm buying these offsets." And you really, for the most part, there's no way to actually prove that it is carbon neutral with those offsets, unless you're doing really intensive measurement and verification. And a lot of these places simply aren't. They're saying we planted a tree, the tree's still there, end of story. And so it's a wing and a prayer sort of thing. Geospatial AI is I alluded to it. It's basically you're taking AI, you're looking at a location. You could also be looking at a point in time, and you're understanding the environmental risks, what's around that location, what's changing, what's not changing. So, if anybody here has ever heard of the First Street Foundation, they look at flooding risk in might be more than just the United States, but I know it's definitely the U.S. While their technology is a black box, they are using some sort of machine learning to forecast out where buildings' flood risk is. And so, for those of you who aren't aware, the FEMA flood zones and the FEMA flood hazards, they look at historical data, and that is how it's assigned. As we know, with climate change and more extreme precipitation events, you're seeing flooding that happens outside of FEMA designated zones. And that's because FEMA only looks at what has happened. So by looking at what has happened and modeling weather and climate, now you can start to take in some really good information, run simulations to say, this structure, it's a football field away from the FEMA flood zone, but we know that a 100-year storm is going to flood it out. And then that can be applied in a multitude of industries. The insurance industry is very, very interested in that right now. So are a lot of asset managers. And then forecasting. A lot of what I do and have folks that contact me and want information, they want to know, they want a crystal ball. And you get into conversations of accuracy versus precision. But essentially, a lot of my use of AI from the sustainability is what patterns have we seen? How does it equate to your current real-time data usage? And how can we leverage that to shave off, say, for instance, energy use? If we know what you've used for natural gas and electricity the past 10 winters, we can look at how many, it's called a degree day, and that degree days is a way that energy folks, well, also farmers, look at how much essentially heat is produced or not produced. It's different. It's not saying like, oh, today's a 68-degree day. There's an equation involved, but essentially you can look at degree days and energy use, run a simple linear regression, and you can see, okay, I'm using the appropriate amount of energy based on the degree days for this heating season or cooling season, depending on what you're interested in. But what's cool about that is then you can start to extrapolate and forecast out. and that can help make real-time decisions on your campus. So, for instance, what technology you might want to utilize when you're building a new building, or do we add different controls to the buildings? Um, and so I'll just take a quick second and pause to see if anyone has a question, because I know sometimes people get shy and don't want to interrupt. Okay, I will continue. So why do we need smarter tools and fast? Well, I assume since this is a sustainability course, or sustainability course of study, everybody here understands that climate change is happening. Um, Everybody understands that pretty much everyone in the world is impacted some way or another by climate change. It might be more direct, it might be more passive, but it's happening. Our greenhouse gases and emissions are growing. And a lot of countries, a lot of institutions, they used to have these 2030 net zero carbon targets, and now they're being pushed back to 2050. And I imagine within the next couple of years, we'll start to see 2065 or 75. They just keep passing the buck, so to speak. Um, and so, if we understand that a lot of our environmental challenges are actually data problems, and we start to think of it through that lens, AI opens up this entire world of us being able to run these scenarios, run these models, run these estimates, and then say, this is our accuracy rate. And knowing that if we have an algorithm that's running at about 80 to 90% accuracy, okay, that's pretty good. And hopefully that is enough to get sometimes there are obstacles within organizations or countries to get you to listen to these models and to take it from this is a, and I'll be frank, you're going to hear it eventually. Well, that's a hippie tree hugger sustainability person. This doesn't matter. But if you come forward and say, well, this is the model, it's at 88% accuracy, it's saying that it's going to cost our organization this much money if we don't do anything over the next 5 years, suddenly folks hopefully will take you a little more seriously. And a great example of that, and I'm dating myself here, but when people began switching over to LED light bulbs in a commercial or institutional setting, there were a lot of chief financial officers, even a lot of facility officers who just didn't believe that an LED was going to get the the savings and the gains over a fluorescent tube light bulb. Um, and so by being able to actually model out how much energy use you're using, and it's just pick your classroom, for instance, you've got 30 lights. Well, instead of using 60 tube fluorescents, each at 13 watts, you switch over to one LED that's now, say, 8 watts. You do the simple math and you can show, hey, we're going to save a lot of electricity here. That's going to save us some money. And that's before you even get into other interesting things. So, for instance, CFLs or regular FLs, they have mercury in them. There's an expense to discard them. There's a regulatory issue when it comes to that as well. So there's a lot of ancillary costs that don't usually get added up. But it also allows us to understand water scarcity, quality monitoring, where emissions are coming from, and then biodiversity. And I'll say too, I know some people are probably thinking, yeah, but AI is all over the news, and AI is using a ton of energy. AI, or going to take a ton of energy, or AI is going to take a ton of water, or AI is going to generate a ton of pollution. And so, yes, if it is done in these, depending on how it's done, yes, it can. What a lot of folks don't always realize, though, is you can actually have your own artificial intelligence system running on your laptop. And I don't mean you're going to chatgpt.com. You can do an open source thing that is running on your system, on your computer. So your emissions from that AI model are whatever your computer's power usage is. Um, Olama is what I use for a lot of things. A lot of the data centers that you hear about, those are going to be needed when, say, you are crunching terabytes or petabytes of data. That's when you have a ton and ton of data. But you don't need a whole data center to take this video recording and turn me into a talking kitty cat. You can do that on your computer. I'm not going to tell you how, but you can do it on your computer because I don't want to see myself as a kitty cat. So some real world AI applications. I talked about First Street and climate risk. Um, Another very popular usage of AI and climate risk is out west dealing with wildfire, so that they're trying to predict where wildfire is going to occur. And an emerging usage of AI and climate risk is in ag tech. So understanding how to get good crop yields, trying to forecast out when some problems might occur from maybe it's drought or pests. Uh, I follow that space because I just find it very interesting. As you see, precision agriculture is the very one next to it. Um, but both of those clearly are tying into the UN Sustainable Development Goals and thinking about where things are as we move forward. We also have water quality monitoring. So for those of you who aren't familiar with the Chesapeake Bay, um, or at least the water quality issues around the bay, there's a lot of runoff from industrial agriculture. There's also, you've probably heard it in the news, there's been some discharges from wastewater treatment plants, both down in DC and up where I am in Baltimore. Um, and so, how can we look at the water quality, continuously monitor it without necessarily having to add more sensors? And how can we kind of forecast where those plumes are going to go so that we can be strategic in when something happens, how to clean it up? Um, which also kind of goes hand in hand with emissions intelligence. In the regulatory world, you'll learn an emission is basically anything that escapes the boundary of that facility or that process that shouldn't be. And so water, what I mentioned with the runoff, that's an emission. An emission could be what you typically think of coming out of a smokestack or out of a tailpipe. But there's really interesting computer vision technology coming out and satellite technology that's allowing us to track emissions. So, for instance, you can track methane emissions from satellites. And why does that matter? Because that can show you where some methane super polluters are. If the satellite has decent enough spatial resolution, you can start identifying where leaky abandoned wellheads are. They're all over Pennsylvania. They're all over Texas and Oklahoma. And essentially, these are old oil or old gas wells that somebody gave up on a long time ago. They may have been sealed properly, they may not have been sealed, but essentially nobody's checked on them. So they're leaking stuff. Um, it's really interesting. I could go on for a long time about where kind of emissions intelligence is going. And then I also get very much into the spectral side of things. So satellites see more than just regular colors. They, depending on what sensors they have, they pick up on a whole spectrum of invisible colors, whether it's near infrared. Um, some pick up on UV. Hopefully, in the next few years, they'll have some really good forward-looking infrared thermal satellites. Um, Energy demand forecasting. I've spoken a little bit about that. I actually made this presentation way before we were facing the current chaos in the Middle East. We're going to hear a lot more about energy crisis. here in the next few weeks. You're probably already hearing about it. And so, how can we look at demand pricing, whether it be oil, natural gas, car gasoline? But essentially, how can we look at all that data, find patterns that would take humans months and months and months, and extrapolate out what the usage is? And then once we move forward and go back, hopefully to a atmosphere, at least in the United States, that believes more in renewable energy, what are the opportunities there to locate renewable energy resources to offset fossil resources? And how can we look at that on a time frame, knowing that your average solar panel, an average wind turbine has a 20 to 30-year lifespan. And how do we plan for that? What do we look at so that we don't install it all today and then in 19 years be like, uh-oh, now we're going to lose all this information on the grid, or all this energy on the grid, and that data center is going to go down. How do we think about that? And then something that I'm extraordinarily passionate about is environmental justice. So I've created a few platforms, and I can share them with anybody who's interested, that actually are leveraging environmental justice data sets and pollution data sets so that frontline communities can use AI to not replace experts, but to help supplement their fights, whether it be about clean air, clean water, whatever it may be, and so that we can actually expedite the expertise level at these communities, help them leverage what used to be just reserved for high level consultants, or colleges, and really take the fight to their town hall, their county hall, whatever the appropriate thing may be. And essentially, you can take a small 3-person, 4-person organization with no computer skills, with a little bit of training, um, and a little bit of custom AI work. Now all of a sudden, they have information just as good as the county council, and it's very powerful when you're able to go in front of your county council with their own data and show what the problem is, as citizens. And when they say, where did you get this flooding data? I go, well, that your own engineering department published this open data set, and this is what it's going to look like. Because sometimes there's a disconnect, and the information internally doesn't always flow to those folks. Whoops. So real projects. So I mentioned environmental justice. These are all things that I've created over the past couple of years. Um, they all use some sort of AI. So I'm not the best at naming stuff, but Eco Guardian, it's just a simple, I say simple, but it's an AI platform for frontline communities. It brings in the old Justice 40 data sets, the EPA environmental screen data sets, and basically has a chat bot that allows folks who are not environmental scientists to say, what pollution is it? What pollution impacts me at my house? And then it presents the information in a lay public friendly way, as opposed to saying, for instance, oh, well, you live by 18 toxic release inventory sites, emitting X amount of ppm of this. It distills it down to say you live by 18 polluters. The major pollutant coming out of it is toluene. Um, so that folks can. Oh, okay. Yep, I can definitely share that. Share some links with folks. Whoops, after it. Sorry, I made the thing get in the way. Quant Agri is something that I created. I've been trying to grow. It's a forecasting tool that looks at agricultural commodities. It's using NDVI and DWI. So NDVI is a measure of greenness, NDWI is essentially a measure of wetness, and it's trying to show if a crop, particularly soybeans, wheat, or corn, if there is a stress on that crop, looking at the major regions of it, and it's actually beating the markets by about 20, 25 days. And so why does that matter? Well, if you're an ag commodities person, it's a way to make money. But really what interests me is there a way that we can use that intelligence so that folks can understand that there might be a massive crop failure, or there might be a massive crop surplus, and what will that mean for communities that rely on those crops for their economic livelihood, or rely on those crops to feed themselves. Um, so it's basically in that instance you're using free satellite data from Sentinel. It's constantly aggregating the data. And forgive me if I get too technical on anybody. Essentially, it's every day GitHub fires an automatic action. It sees if there's satellite imagery available, what the cloud cover is, and then it looks at that satellite imagery and calculates the NDVI and DWI, and then it compares it against historical information. It also compares it against a machine learning algorithm, and then then it dumps out and says, "Yep, it's the crop's where it should be. Nope, the crop's underperforming," or "Yep, the crop is doing well." And then anchor flow, that once again, I did all this before the chaos, but it's looking at natural gas infrastructure and pipeline issues. And no, I don't think natural gas is a sustainable fuel. However, there's a lot of folks that will say natural gas is a clean fuel and they'll want to talk about it. And it plays a role in some asset level sustainability plans. So trying to figure out how you can not compromise your own beliefs and your own ethics, but you also want to be able to work to advance whatever you're working on. And I have found over the years that if you can find ways to help people save a little bit of money on natural gas, and reduce natural gas emissions, sometimes you buy yourself a little bit of leeway to then chase things that your bosses or your organization don't care as much about, but you do. So, for instance, organic waste diversion or composting, that's usually a popular one. So you're trying to do a little trading there, essentially. So the AI pipeline, as I tried my best to make this as simple as possible. Um, so for those of you who have never really used AI before, it always starts with data. Uh, there's lots of bad data. Um, so you want to get as decent data as possible. Lots of times your data will be unstructured data, it'll be raw data, it'll be unclean data. So you want your data to be as structured and as clean as you possibly can. And it's always okay to ask and say, I don't get this. How can I make this clean? Or, what's wrong with this? Because the cleaner and better structured your data is, I promise you, the easier your project and the easier life is going to be, which is, as you see, number two. And it's that old saying, garbage in, garbage out. That hasn't changed. It came about, I think, in the 70s with computers, and it's the same thing today. If you put in, I'll use a super easy one. Say you're doing an emissions inventory of your college, and you accidentally fat finger in it was negative 100 metric tons of carbon coming from the physical plant. Um, why you would hit the negative sign, I don't know, but that's garbage data, but that's going to show at the end of the day, you now have a delta of minus 100 metric tons of emissions, even though there's no way your physical plant had minus 100 metric tons because they're probably combusting natural gas to run the boiler, or maybe, well, probably natural gas. I doubt they're using heavy oil anymore. So that's just a very easy example. Um, you want to do your best. Mistakes happen, and it's just as you analyze more data sets, you'll learn to see those mistakes. You'll learn what to look for, and you'll be able to kind of look at it and be like, oh no, something's wrong. And if you pick a niche and you're really good at it, you can probably find right away exactly where that mistake happened. But it's going to happen. It's okay. It's just a matter of going back and figuring out. And I always tell students that's why documentation is very, very important. It doesn't have to follow any format per se, but you always want decent notes. You want to be able to reproduce whatever you did, or you want to be able to give it to a friend or a colleague and have them reproduce it. Um, if you can't hand over a set of instructions to somebody to reproduce it, then you need to question, is the analysis ready to go? Is it worth doing? Then you train the model. This is usually can be some of the longest part, depends how much data you have. So for instance, when I was talking about the Quant Agri stuff, just to do Brazil, the Mato Grosso region in Brazil, where a lot of soy is grown, that took to run the historical back 10 years after I fooled GitHub a few times, that basically took about a day and a half to run that algorithm. I know people who are dealing with much even bigger data sets where even if it is going to a data center, sometimes it can take days. Um, Hopefully nobody has data that big yet, but you really, you need to train the model, set aside some time, and then test and validate. Um, I even to this day, if the first time I run the model, if everything comes out looking really good, I start to say, okay, did I mess up? Part of that is just, I guess, the perfectionist in me. Um, but it's always good to test your data. You want to validate it. As I have learned being a dad of a 17-month-old, twice is a coincidence, three times is a pattern. Try to live by that. Um, if you can get approximately the same results three times, you have a pattern, and it probably means something is either working or failing miserably. And then just kind of do what I call the idiot check. Does it make sense? So if you're estimating emissions, once again, and there's no direct carbon capture involved with your emissions, then if your model keeps telling you that your emissions are in the negative and growing, that makes no sense. So what's going on there? And then finally, deploy and monitor it. Um, that's sometimes the scariest part, and that's letting the model out into the world. Um, it's letting other people look at it, criticize it, but that's just part of really what I call the academic process, the real world process. You want folks to criticize it. You want them to ask questions. I always tell people when there's something new, please break it or try to break it, because that's a learning experience for me. That's a learning experience for your team, and it really presents opportunities to find weaknesses. What I didn't put in here is if you've probably heard of SWOT analysis, strength, weakness, opportunity, threats. That can always be applied to your data pipeline. Um, you really want to look at, what's strong about it. What do you think the weaknesses are? Where are your opportunities to improve? And are there any threats? Are you making bad assumptions? And really think that through and talk that through. Um, so, location data, I'm very big on geospatial. And when we're talking about sustainability and in the environment, pretty much anything you can think of has a geographic dimension. So where is it happening? I'll add to that. You can also think of the z-axis. How high is it happening? So maybe it's a building, or maybe it's dispersion of pollutants from a smokestack. So you always want to think about that. And then from a time perspective, how often is it happening or not happening? And so I've probably beat this one to death, but you can do satellite change detection. Sometimes it's as simple as you're taking two satellite images that are a year apart, and you're classifying what you see on the ground. So you've probably all seen images after a hurricane, for instance. So you could do a quick change detection, and you could see the amount of destruction in a neighborhood. You take a satellite image that was before the storm, you take one right after the storm, and you can then train the model to show you, for instance, how many blue tarps are on the roofs. You could easily do deforestation. If you have a look at the model, you run it, and you have a forest that's 100 hectares, and then a year later you run that model, and now suddenly that area is 50 hectares, and the other 50 hectares are streets. You have deforestation. Glacial retreat's another very interesting one. Infrastructure vulnerability. That's I just read an article the other day. There's a company working out, I forget if it was New Mexico or Arizona, where they're actually identifying from satellite imagery leaky or broken pipes that can't be seen um, by an observer. They're using something called synthetic aperture radar, SAR data. It's all proprietary, so I don't know exactly how they're doing it, but the county or the town that hired them is very happy because they have found like 50 leaks that they didn't know were out there. And when you're in a desert community, having water leak out from your pipes into the surrounding area is not something you want. But you can also look at utilities at risk. So one very popular thing to use with machine learning is to look at utility corridors, right-of-way areas, and understand where the trees are, how tall the trees are. If a tree falls, will it hit the wire? It's vegetation management essentially. But the interesting thing there is if you have thousands and thousands of miles of wire, but you don't have the budget to send somebody to go check on it every 3 months, you can use this satellite imagery to identify spots that are the most at risk. And then you can deploy your folks to those 10, 15 areas and have them cut the trees or prune whatever they might need to do. Community risk, that's always back kind of to the environmental justice idea of understanding how communities are at risk, whether it is from man-made things or natural things. Uh, there's always the density issue. Is it a highly dense area? There are tons of people there that'll be impacted versus a small town out in Oklahoma where there's only 100. But it's an interesting way to kind of, if you say you're an organization and you have a grant um, for climate change adaptation, then you can start to say, well, yes, this adaptation mechanism that we could put here can impact 1,000 people, but their risk from this climate issue, say flooding, is very, very low. Whereas we could look at, say, Tangier Island in the Chesapeake Bay, which is actually a bad example because you could argue that the risk is so high it's not worth putting any money into it. But you look at a high risk and a lower population, and then you kind of get into those policy discussions of where do we go with that. And then urban navigation. I wanted to bring that in specifically because people that are differently abled are often forgotten in this space. And so I always challenge my colleagues, students to think about how can we make this work for somebody that's differently abled. And so, Google, for instance, you can have it map you a location and how to walk. Okay, great. But if you're in a wheelchair, or even as simple as you broke your foot at soccer practice and you're on crutches, um, the way that you might have always gone is going to now become very different because you have different things to think about. Also, too, for folks that are visually impaired, okay, great, colors on a map might mean nothing. They might not be able to see the colors. They might not be able to even see the map. So thinking about how you can structure the data responses in a way that it still can bring some sort of insight and value to those folks. So how can you build a career in this? That's probably what everybody wants to know. Um, I'll be honest, I put AI ML engineer on there unless you are extremely computer driven. I would imagine most sustainability folks aren't going to go that path. Um, it's mostly tech companies. There are some startups. The biggest barrier there for folks is going to be, and I fight this a lot, I don't have a background in computer science. Um, they want to see that box checked, but that's the most obvious way to get in there. Environmental engineer, uh, in this country, you'd actually have to be an engineer, have that professional engineering, um, that PE. However, you can get in there as an environmental analyst, environmental specialist, and essentially you're an engineer in everything but name. I left it as an engineer on purpose when I made this slideshow because a lot of European countries, that's kind of how it works, or at least that's my understanding. Uh, Geospatial, pick whatever job title you want, but geospatial data scientist, uh, that's what it says it is, using lots of GIS, lots of spatial analysis. Um, an interesting thing that kind of falls under that is public health. There's a lot of folks that do geospatial that suddenly had their 15 minutes of fame during the COVID pandemic when we all would see those maps on TV, and we're like, "Oh man, look, that's a Esri dashboard, and that's what I do." I know for me it was a big deal because my mom was like, "Wait, isn't that what you do?" And I said, "Yeah, only I'm not counting how many people are being killed by a virus." But it is there's an opportunity there, and as most of you know, there's a lot of environmental issues that tie in nicely with public health. Sustainability consultant, that's also pretty obvious. Um, I will say, in right now is not a good time to be looking as a sustainability consultant due to political constraints. There are some opportunities available for that, but they're few and far between. We'll just leave it at that. Climate data analyst, same story. There are probably your best bet there is going to be a nonprofit or a state government, to be very frank with folks. The Northeast has really good opportunities. So does out West. And occasionally, Florida ebbs and flows as to if you can even say climate change. But Florida local governments have a lot of opportunities for climate data as well. And then the one that's probably going to be the lowest paying, but potentially the most rewarding, is environmental justice. And working with groups who are working with frontline communities that have been forgotten about or abused. Um, I've had the opportunity to work with many of these groups over my career, and I love doing it. And you can pretty much take whatever your environmental or data interests are, and you can find communities that need that help. So that is where I'm pretty much done here, but I have a few questions for folks to kind of think about. You all can read, plus your faces are in my way, so I'm not going to read them to you. But are there any questions?
All right.